Hi everyone. In this video, I'm going to explain what you mean by bubble sort and how to sort the given set of elements using bubble sort, which uses brute force technique. Okay. So again, I'm telling this bubble sort uses brute force technique. Okay. What do you mean by sorting? So many students will tell. So when asked this question, what is sorting? People will say sorting is the process of arranging the given elements in either ascending or descending order. It's absolutely right, but not 100%. Okay, so it is not arranging, it's a process of rearranging. Just instead of using the word arranging, use rearranging, because already the given numbers are in some order that we are rearranging into either as an ascending or descending order. So a sorting is the process of rearranging the given set of elements either in ascending or descending order. Okay, so now how this bubble sort will works? So this bubble sort compares the two consecutive elements. Okay, consecutive elements means continuous elements. If they are in order, means first number is lesser than the second number, then we are not doing anything. If the two numbers are not in order means the first number is greater than the second number, then we are swapping these two. Okay, assume here in the bubble sort we are rearranging the given set of elements in ascending order. Okay, so let us take, these are the numbers 9, 5, 2, 7, 1. These are the numbers we need to sort in ascending order. So how this bubble sort will sort? So first it will compare the two consecutive elements. Now the first two consecutive elements I'm checking. These two are in order? No, these two are in not order. What we have to do? We need to swap these two. So when I compare, these two numbers are not in the order. I swapped these two, remaining element I kept as it is. Next, what you have to do? Next two consecutive elements we need to check. Now I'm comparing these two elements. Again, these two elements are in order. No, again these two elements are not in order. So what I will do? I will swap these two remaining elements as it is. Similarly, what I have to do? Next two elements I need to check whether these two are in order or not. These two elements is in order? No. Again, we need to swap these two elements. So that is, we are swapping only these two remaining elements as it is. Okay. So next what I am doing? So next I am comparing next two consecutive elements. Again, these two are not in order. So I will swap only these two remaining element as it is. So after the first pass, so okay, this is my first pass. Pass 0, I'll say pass 0. Okay, so after the pass 1, what we did, we compare the consecutive element. If they are in the order, we are not swapping. If they are not order, we are swapping by keeping remaining element as it is. Now, if you observe among the given elements, which is the maximum element? 9. So that if you observe, that maximum element we kept at the last. Once the array is sorted, which element has to be at the last position? If you are sorting in ascending order, the last element should be the maximum element. That what we did here. Okay, so that means we bring the largest element at the last position. This is what we did in pass 0. The conclusion is, at the end of the pass 1, we sorted one element, that is the maximum element. Now what are the remaining elements? Now remaining elements what? This is 5, 2, 7, 1. Now these elements, now again we have to do the same process. That means again check the consecutive elements. These two elements are not in order. So what you have to do? Simply swap these two elements, keep remaining elements as it is. So again I compare next two consecutive elements. These two elements are in order, so I am not swapping. So I am keeping as it is without doing anything. So again I am comparing next two consecutive elements. These two are not in order, so I am swapping only these two by keeping remaining element as it is. Now this is the end of what? Pass 1. So after pass 1, what we find out? We found the second largest and we kept at the second last position. This is the first last. From here, this is second last. Okay. So at the after second pass, second round, we found the second largest and we kept at the second last. So now remaining elements are what? 2, 5 and 1. Now again the same process. Again I am comparing these two consecutive in order, and these two are in what? Order. So I am keeping as it is without doing anything. Okay, next I am comparing next two consecutive element. These two are not in order, so I am swapping these two and remaining element as it is. Now this is the end of what? Next pass, that is pass 2. Pass 0, pass 1, pass 2. So after pass 2, what we find out? We find third largest and we kept at the third last position. Okay. Now we left with what? Two elements, that is 2 and 5. Now check whether these two elements are sorted. So I compare these two. Sorry, not 2 and 5. This is actually what? 2 and 1. This is 2 and 1. Now again, after comparing this one order, no. So I swapped these two. 1 and 2. So this, that's it. Now this is the end of the pass 3. So after pass 3, we got the fourth largest and we kept it the last. Now remaining element is only 1. So see, this is the remaining. So finally, when you observe from the at the zeroth position, finally I'm having what? 1. So this is 1. At position 1, what I'm having? 2. So at position 2, what we are having? Position 2, we are having 5. At position 3, what we are having? 7. At position 4, what we are having? 9. Okay, so thus we sorted the given elements using bubble sort in ascending order. Okay. Assume here how many elements we took? We took 5 elements. For 5 elements, we took how many passes? We started with pass 0, we named it as 0, but 1 pass, 2 pass, 3 pass, 4 pass. So for 5 elements, we took what? 4 number of passes. Suppose assume there are 4 elements are there. The 4 elements means, so you take from here, okay? You leave up to here, okay? So now we are having what? Only 4 elements. So how many passes we took? 3 passes. It's clearly observed, right? So if you are having 4, only 4, we take 4 elements. See 1, 2, 3, 4. So then we are having 1 pass, 2 pass, 3 pass. So for 4 elements, 3 passes. Similarly, if you take only 3 elements, see with the take only 3 elements, 2, 5, 1. 3 elements, how many passes? 2 passes. Okay. So that means for 3 elements, we took only 2 passes. Similarly, if you take only 2 elements what? How many passes? Only 1 pass. So for 2 elements, we need only 1 passes. Similarly, if there are 6 elements are there, how many passes? Yes, exactly 5 number of passes. So in general, if there are n number of elements are there, we need what? N minus 1 number of passes. This is one conclusion what we got. Okay. Now in each pass, how many times we compared? See in the pass 0, how many elements are there? 5 elements are there. So how many times we compared? 1, 2, 3, 4. So in first pass, 5 elements, 4 comparisons. Okay. 5 elements, 4 comparisons. So in second pass here, okay. How many elements? 1, 2, 3, 4 elements. How many comparisons? 1, 2, 3 comparisons. Similarly in this, 3 elements, 2 comparisons. 2 elements, 1 comparison. So in general, there are n number of what? Comparisons in each pass. In each pass, n minus 1 number of comparisons. So to sort n elements, n minus 1 number of comparisons. Okay, now hope you people understood. With this information, now we'll write the algorithm. So here I have given the name of the algorithm as bubble underscore sort, and the parameter to be passed is array to be sorted. Okay, so a of 0 to n minus 1. Now here, whether we repeated anything, if you observe here, yes, we repeated the number of passes and comparisons. So whether we are doing comparisons inside the passes or comparisons inside the passes or passes inside the comparison, in each pass we did some number of comparisons. In each pass we did some number of comparisons. So 2 loops we have to use. We repeated 2 things. Number of passes we repeated, number of comparisons we repeated. So we have to use 2 loops. So which loop? So here we know exactly how many number of times we did the passes, right? How many number of passes? N minus 1 number of passes we did. Okay. So since we know exactly how many number of passes we did, so I'm using for loop. So for I is equal to what? 0 to n minus what? 0 to n minus 1 or n minus 2. See, if you observe, I started with what pass? Pass 0. Then pass 1, pass 2, pass 3. For how many elements? 5. 5 elements ends at 3. So 5 minus 3 is what? So 5 minus dash is equal to 3. How much? 2. That means it is n minus 2. Okay. So we have not taken. Suppose assume you started with 1, pass 1 instead of 0, pass 2, so 3, so 4. So then you are comparing, we started with 1 and then 2, 3, 4, 1 lesser than the number of elements. Okay, here 3 lesser than elements, so 2 lesser than the number of elements. I took n minus 2. Suppose no need to write 0 to n minus 2 only. If you start passes with 1, okay, pass 1, pass 2, pass 3, pass 4, then you can write I is equal to 1 to n minus 1. Okay, but since I started with 0, I started with I is equal to 0 to n minus 2. So do what? Now inside each passes we compared. Okay, how many times we compared? Exactly n minus 1 comparisons we started. Again, since we started comparing from that 0th position, see this element we compared with next element. This element I compared with this one. This element compared with this one. This element I compared. I stopped last but 1. I not compared this element with anyone. Okay, not compared this element with, see, last element I have not compared with anyone. So this element we are not compared with anyone. This element we are not compared with anyone. This element we are not compared with anyone. This element we are not compared with any other element. We stopped at its previous, last but 1. See, we stopped comparing the previous one only. We start comparing of the previous one only. We stopped at the previous element only. So we'll write for j is equal to 0 to n minus 2 only. And in every pass we are using one element. See, in the first pass 5 elements, second pass minus 1 element, that is 4 elements. In the second pass 2 minus 2 elements, that is 3, 5 minus 2. In pass 3 I reduced by 3 elements, so I got only 2 elements. So in every item I am keep reducing, so minus by how much? By I number of passes. Okay, initially pass 0 we not reduce anything. 5 minus 0, 5. So next is 1. 5 minus 1, 4. 5 minus 2, 3. 5 minus 3, 2. So n minus 2 minus I. Okay. If you not understood, we will see in the tracing. Well, okay. So now what? Now we will try for comparison. Okay. What we compare? The first element with the next element. So I am taking for that purpose j here. So I am comparing one element with its next element. So I will write if a of j, I am comparing with what? A of its next element, a of j plus 1. Now what we compared here? We compared whether the first number is greater than the second number or not. If the first number is greater than the second number, is swapped. If you observe here, see 9 is greater than 5, we swap 5 on 9. Okay, suppose, see, if the two numbers are not, first number is not greater, we kept as it is only, we are not swapped here, if you observe here. Okay, we swapped only when the first number is greater than second number. So I want to check if a of j is greater than a of j plus 1, then what we have to do? Then we need to swap what and all? A of j and a of j plus 1. That's it, the algorithm. If we come out of the outer for loop, by that time our array will get sorted. Okay. Hope you people understood. This is the algorithm for that. Now let us trace this algorithm. First, initially what? I is equal to 0, n minus 2. Here n is equal to what? N is equal to 5. So this 5 minus 2 is nothing but 3. So this n minus 2 minus, okay. So again this n minus 2 is nothing but what? 3. 5 minus, because we have taken n is equal to what? 5 elements. So 5 minus 2 is 3. Okay. Now 0 is less than or equal to 3, true. So I have taken I. So passes for I told for number of passes. So I take 0. So next I will take what? J. J I have taken at what? 0. 0. J I have taken 0. So it is less than or equal to 3 minus I. I value is 0. So 3 minus 0 is 0, 3 only. 0 less than or equal to 3, true. Comes inside. Now A of j value is what? J value is 0. So a of 0 greater than a of j plus 1. So that is a of j 0 greater than a of plus 1. A of 1. So that means I am comparing a of 0 with a of 1. So that means I am comparing these two. These two, 9 is greater than 5, true. Control comes inside swap. We swapped. Okay. 5 and 9, remaining element as it is. Next what? After that, control goes to the increment part of the jth for loop. J will get incremented. Now J will get incremented to 1. So now what I did, now J comes to here. J comes to here. So now again J becomes 1, 1 less than or equal to 3, true comes inside. Now A of 1 I am comparing with A of 1 plus 1, that is A of 2. That means I am comparing A of 1 with A of 2, and these two I am comparing. Again this is greater, control becomes true, condition becomes true, comes inside and swap. Okay, these two get swapped. Okay, so next goes to the increment part of the J for loop. Now J becomes 2. J becomes 2. I'm not writing here. I'm writing here. J becomes 2. So again 2 less than or equal to 3. True comes inside. Now A of 2 I'm comparing with A of 3. That means A of 2 I'm comparing with A of 3. Again this is greater than this one. So I'm swapping. So next goes to increment part of the jth for loop. Now J becomes here. J becomes 3. 3 less than or equal to 3. True comes inside. Now I'm comparing A of 3 with A of 4. Again condition is true. Comes inside. It swaps. Okay, 1 and 9. So now again J get increments. J becomes what? 4, but 4 less than or equal to 3, condition false. Now it comes out of this for loop. Now control goes to the next iteration of the ith for loop. Now I becomes what? Now I from here, I is equal to 0 earlier. Now I becomes what? 1. I becomes 1. Now again I 1 less than or equal to 3, true comes inside. Again J is reinitialized to 0. That means now again J comes to here. Now again I'll compare A of J with A of J plus 1. Okay, greater, I swapped this. Again increment. Now J get increment. Now again I'm comparing A of J with A of J plus 1. Again, but the condition false. A of J is not greater. Comes out of the if block. Go to the next iteration of the jth for loop. J becomes now what? 2. 2 less than or equal to 2, true. Here now 3, I value is what? I value is 1. 3 minus 1 is what? 2. So now J value is also 2. 2 greater than less than or equal to 2, true comes inside. Now A of 2 greater than A of 3. A of 2 greater than A of 3, I am comparing this one. Okay, true comes inside, I am swapping. I swap these two. So then goes to the increment part of the jth for loop. Now J comes to what? 3. Now 3 less than or equal to 2, false, comes out of this for loop. Goes to the next increment part of the ith for loop. Now I becomes what? Now I becomes 2. Okay, now again comes inside. 2 less than or equal to 3, true comes inside. Now J is initialized to what? Here. Now again A of J, now J value is what? 0. N minus 2 is 3. 3 minus I value is what? 2. 3 minus 2, 1. 0 less than or equal to 1, true comes inside. A of 0 is comparing with A of 1. I am comparing these two. Condition false, comes out of the if block. Go to the next iteration of the jth for loop. Now J becomes 1. So now again 1. Now J becomes 1. 1 less than or equal to 1, true comes inside. A of 1 greater than A of 2, true, I swapped, comes inside, swapped. Okay, then go to the increment part of the jth for loop. Now J becomes 2. 2 less than or equal to 1, false, comes out of this for loop, goes to the increment part of the ith for loop. Now I becomes what? I becomes to pass 3. Now it can also pass 3. So now again J is initialized. J initialized to here was 0. 0 less than or equal to 0, true. Now you see N minus 2 is 3. I value is what? 3. 3 minus 3 is 0. 0 less than or equal to 0, true comes inside. A of 0 greater than A of 1. I am comparing these two. These two are condition is true, comes inside, swap. I swapped. After that J get incremented. J becomes 1. 1 less than or equal to 0, false, comes out of the for loop, goes to increment part of the ith for loop. So now I becomes what? 4. I from 3 to I becomes 4. So now 4 less than or equal to 3, false, comes out of the for loop by the time array is sorted. This is how that bubble sort works. Now we need to do analysis of this algorithm. So we know that first step is to decide the problem size. Here how many number of elements we are sorting. Yes, in this example 5, but always we are sorting 5 elements. No, it may be 5, 6, 8 in whatever. So number of elements to be sorted is n. This is the problem size. Second step, we need to identify the basic operation. Actually, what is the operation we did? Whether we did any addition, subtraction, multiplication, nothing. We did only one operation. What is that? Swapping and comparison. And swapping we did based on the result of comparison. So our comparison operation is the what? Basic operation. Comparison operation is the basic operation. So comparison operation A of J greater than A of J plus 1 is the basic operation. So the third step, so we need to decide whether we need to find only the average case or all the 3 cases. Here however you give, however you give the input elements, we need to do all these operations. Okay, even though if you give in complete reverse order or in the ascending order itself, we have to do all these things. Okay, so it depends only on the number of times basic operation executed, depends only on the problem size. So we need to find only the big theta, that is average case. Now fourth step, since it is non-recursive algorithm, we need to express how many times this basic operation executing in terms of some expressions. So here two for loops are there in our algorithm, so we are using two for loops, okay, two summations. Since comparison operation, so I am writing C of n is equal to summation, two for loops, two summation. First for loop is I is equal to 0 to what? N minus 2. I is equal to 0 to n minus 2. So 0 to n minus 2. Next for loop is, inner for loop is j, that is running from 0 to n minus 2 minus I. So j is equal to 0 to n minus 2 minus I. And for each iteration of this for loop, this comparison operation we are executing only once. So we are writing 1. So now apply formula for this. Now if you apply formula for this, we know the formula, upper limit minus lower limit. So upper limit minus lower limit plus 1. So this is minus 2 plus 1 becomes minus 1. So this becomes I is equal to 0 to n minus 2, n minus 1 minus I. Now here I is the only variable and the value of I is depending on only here. N and 1 is constants. Okay. So now if we keep replacing the value of I. So first of all, first I'll keep the value of I as 0 because I value starting from 0. Next 1, 2, 3, 4 up to n minus 2. 0 summation plus next value of I is 1. So next value of, okay. So if you replace I value by 0, what happens? N minus 1 minus 0 is n minus 1. Then summation. If you keep I value is equal to 1, then n minus 1 minus 1 is n minus 2. So like that plus n minus 3. It keep decreasing. At one stage it becomes 0. So if this is the formula, then we know that it can be written as n into n minus 1 divided by 2. So this can be written as n square minus n by 2. This can be written as n square by 2 minus n by 2. Okay, that means exactly this many number of times our basic operation is executing, comparison operation is executing exactly this time, this number of times. See, observe here, how many times we compared? 1, 2, 3, 4. 5, 6, 7, 8, 9, 10. 10 times. For how many elements? 5 elements. See, replace n by 5. 5 square is how much? 25. 25 minus 5, 20. 20 by 2, 10. So exactly we are using 10 times. Here also we got mathematically, we proved that. So this is what mathematical analysis. Now out of these two terms, which is the most dominating term? N square. Okay, so we'll write C of n belongs to what? Big theta of n square. So this is our time complexity of bubble sort. Hope you people understood. Thank you.